to start with, there's probably a bit of a misconception in the industry that a house needs to breathe, and many people think that this house needs to breathe to prevent mold. What's everyone's thoughts on this?
Right, I start. I think that obviously a house is not a living thing, so possibly it doesn't really need to breathe. It does need ventilation though, and that's probably where some of the misunderstanding in the industry is. Ventilation is critical. Cam has explained some of it, to control moisture, to maintain good indoor environment quality. But that needs to be controlled ventilation. At the moment, most of our building stock, I would say that has uncontrolled ventilation, and that usually comes in from our wall cavities, from our roofs, from the underfloors, and those are spaces from where we don't want to obtain fresh air. There is a few nasties in those spaces.
Yeah, we are trying to change that language as well, because so often it is houses need to breathe, but no, humans need to breathe. All living things, our pets need to breathe, and so it's more about having the health of these buildings to be, it's the same with actually saying the building is healthy. The building is not healthy or unhealthy. It's about the occupants inside and how their health is affected by the space they're in. So some of these terms where, as you know, we all learn more about building science and building physics, we're trying to be a little bit more cautious around how we use these terms, because the health of people is really important, and the health of the planet is also really important, and so building physics can help address that. And I'll leave Joel, the expert, to talk about actual ventilation and how we keep these homes healthy. No, the people healthy in the homes.
That's it. Look, I don't think there's much extra to add really at a technical level there. I think you've covered that. I think the word breathing buildings comes in the less educated crowds, and they're using it as a justification for building less airtight buildings. I think there's probably, not a lot more detail to add than that.
So maybe then following on for that question, I've already gone off my notes already. So do all houses need ventilation then through mechanical ventilation, or is it just high-performing ones, airtight ones?
Good question. So yes, houses need ventilation. We've always had, well, we haven't always had, for a long, long time, we've actually had bathroom exhaust fans as part of the NCC. So there's our really basic form of ventilation, and that's really about source capture. We have range hoods for the same reason. That's about source capture. So absolutely, irrespective of air tightness, we need some ventilation to get contaminants out of there. As we start to build more airtight, it becomes more critical how we manage that.
But can't we just open our windows?
Can't we open our windows? So good question. So I think most people have probably got practical experience of this, that operable windows could provide some ventilation, but do they reliably provide ventilation? And are they impacted by security? Are they impacted by dust? Are they impacted by noise? There's some good data around that talks about, so done by PHI, around the amount of window open time you'd require to achieve the right kind of indoor air quality, and it's super high. Windows need to be opened every 2 to 3 hours. There's a good Passapedia link for those who know that talk about 3-hourly window opening and closing schedules throughout the day, and no one's doing that in the middle of the night, are they?
I think also you don't understand the outdoor environment. Like, what if the air quality is poor? Plus, we have these things called clients, and you can never rely on them to open a window or door when it's required. And along with that, do you even know the air exchange rate outside that's going to then flush out the air?
Correct. Too little or too much, there's really no control over it.
Do you guys have anything else to add on this one?
Look, I'm based in Ballarat in central Victoria, so the climate is not dissimilar to Melbourne, but it's a bit colder. And so if we are opening our windows every couple of hours, you're desperately, like most homes there are desperately trying to heat them up as it is. Same in Melbourne, right? And so as soon as you have to do that, you're flushing all that hot air out, and this is why heating bills go through the roof, because so many houses are so leaky. It's like having a window like this open, or a metre by a metre square window open open all the time is a typical house. So you're almost, that's not a ventilation strategy, that's leakage. So it's so important if you want some lower heating bills, more comfortable home, to actually consider a different type of ventilation strategy.
And mechanical ventilation pretty much offers you the choice, essentially. Like, you can control it when you want, or as Cam says, you want to hear the birds tweeting outside, just open your fucking window. It's not that complicated, is it?
That's right.
I would probably just point you guys to a videos that Efficiency Matrix just posted last night on YouTube, where Sean from Hadma explained ventilation and how to achieve it in normal houses. And there are, I'll try to explain it a little bit, and then you can watch it in your own time. But essentially, we have high level of moisture at some times within the house, when we shower, when we cook, and then we have residual moisture for the rest of the time. So we need good extract at the times that we create that high level of moisture, and then we need continuous low level of ventilation throughout the day to basically keep drying the internal spaces. You can think of, you have your showers, 3, 5, 10 minutes, whatever. You want your exhaust fan running there, and then you dry yourself with your towels. Maybe there is some water on the floor. That water is going to take a long time to dry, so that's where continuous ventilation. It doesn't need to be heat recovery ventilation. Better if it is, but it doesn't
Joel
need to
would
be.
argue differently.
And that's where it is important.
All right, so when we build a house, should we prioritise energy efficiency or building science? Because just focusing on one means neglecting the other, and which could lead to bigger problems. The issue I feel is that if we build for energy efficiency, you may be ignoring the building science, which can lead to big problems like mould. Whereas if you build for building science, energy efficiency is the byproduct.
All right. I don't know if you can separate them neatly as that. Cam touched on it during his presentation. Building science, building physics is about air flow, energy flow, heat flow, moisture flow, and energy efficiency is about air flow, heat flow. So they're sort of part of the same thing. Now, yes, we have concentrated a lot on energy efficiency, just looking at heat flow, and that's where the insulation and glazing comes in, and we've sort of neglected moisture and airflow a little bit. We're probably getting a little bit better at that, but there is definitely more interest in the market about those type of things. But I don't know if you can really separate them. What I will say is that we need to concentrate on health outcome first, and the energy efficiency then comes after that.
Yeah, I don't have an awful lot to add other than it has to be a holistic approach. You can't do one without the other. It does not make sense. And despite what the building code says or where the building code is heading, if we know this stuff, why wouldn't we do it? Because of the benefits. So,
do you ever ignore the building code because you know the result is better?
Yes, but but we'd have to justify it. Yes.
Through performance solutions, or?
Yeah, sometimes. Well, we have to justify putting in mechanical ventilation with performance solutions, right? So, yes.
Depending on the building surveyor, like the building surveyor I work with doesn't because he understands it.
Yeah, it depends.
Okay.
Yeah.
So I think you've touched on really good points there. I think energy efficiency in its own right is going to cause problems. We're pretty much comfortable with that. It's interesting, my understanding at least is that the passive house whole community industry research started around building a comfortable and a healthy building, not actually an energy efficient building, and that's kind of the energy efficiency is the product that fell out of the bottom of a comfortable design building.
Sorry, I just thought of something to add. There's often that argument about not insulating buildings well, putting in double or triple glazing because, we'll just whack some more solar panels on the roof. So that comes up an awful lot, and the argument then is, hey, we've still got a sustainable building, but it's never healthy. So we are absolutely prioritising, again, not the healthy building, the healthy occupants, by making sure we are always still making sure we've got that ventilation strategy, and that is happening, even if we're not quite getting... when we use the passive house planning package on all of our projects, because that's how we understand that the building science is working as we intended. So if some of our projects in regional areas, you've got 140 walls and that's not enough insulation to meet the passive house criteria for heating demand. And so some of our projects for cost are dropping that performance in terms of a passive house world compared to 7-star world. They're kicking it. They're doing great, but compared to passive house, they will not meet that or low energy. But we've prioritised that we know from a health perspective, they're going to work.
Which probably leads me on to my next question, which is directed at Rob here. So passive house PHPP versus NatHers, and I don't want to make this all about passive house. It's just the easy way to communicate some things. So they're both two very popular and pretty much the only efficiency standards that we can sort of build to, and they often create a bit of debate in the community. However, these two different approaches, they assess energy performance. Can you explain a little bit more how they differ from each other? What's your preference? I'm very honest, and I think NatHers is a load of shit, but you might be able to tell me differently.
I'm probably not going to tell you what my preference is, because I'm going to upset half people in the room, possibly. But no. So let's start with the framework. So passive house, the difference between passive house and NatHers from a framework point of view is that one is aiming to create healthy and energy efficient home. That's passive house. NatHers is a tool to assess compliance or minimum compliance with the National Construction Code, and the regulatory framework in which it sits, it only looks at energy efficiency. It can't look at anything else. That's the framework. Now, if we move to the software, I guess, and the difference there, there are a lot of differences there. And they're mostly around the assumptions that sits within the softwares. To name a few, passive house, or the PHPP, is a one-zone type model. NatHers has multiple zones. There is different set points within NatHers. Your house can range in temperature between 50 and 24, even 29 degrees Celsius sometimes, depending on the zone, depending on the time of the day. Passive house looks at a constant 20 to 25 temperature. The details that you put into your models are quite different when it comes to the building enclosure in terms of their performance. Passive house is much more strict and accurate in the way you assess and determine your thermal performance of the building enclosure. NatHers has some limitation around that.
What are the limitations?
What are the limitations? For example, thermal bridging. Passive house assess thermal bridging in quite detailed. NatHers ignores thermal bridging when it comes to a timber frame and only accounts it for steel frame on external walls. And even the way it calculates the thermal bridging impact of a steel frame is not really the impact, is like a D-rate of the performance of a timber frame. So yeah, this is just a few, but there's probably many more.
And bathrooms don't need to be heated.
Yeah, some bathrooms don't need to be heated.
Airtightness?
Yeah, airtightness is not taken into consideration in regulatory mode, or well, it is, but it's sitting at probably, it ranges, but it's probably between 8 and maybe 12 air changes an hour. Now, some software allow in non-regulatory mode to change some of these parameters and get slightly more accurate results. but not to the extent that you can get out of the PHPP.
So they've thought of it and then gone, but no, we're not going to do it.
I think behind the scenes is the capacity, right?
There is, yeah. It's a gradual step.
So does it have the potential to be better than Passive House then, or PHPP?
Is a tool, and as a tool, it can possibly, has the potential, like any other software and modeling tool, has the potential to do great analysis. It's about what you input as assumptions, and also, I suppose, again, going back to what framework they're working in. So at the moment, Natus is not
To tick box.
Yeah, essentially, yes. It's to stay out of jail. We have to do it. It's to demonstrate minimum compliance.
So what if you use it early in a project to model early, model often? Is it still okay?
Yeah, and that's probably what we will anyway recommend, especially since the 7-star rating has come into play. I don't think that I don't work really in residential space, but I don't think that I can make a house work without a R4 insulation in the wall, a 140 mil stud, and sometimes triple glazing. You might have more experience than me in that space, but so I think it's definitely engage your consultants early on and help you design.
I forgot. You
I'd just pick up Roberto on the Nathers background modelling engine, the Cheneth engine. It is quite good and robust. It's the politics of building in Australia that keeps that tightly controlled in terms of what's allowed to be adjusted and what's not, and how it can be used. So fundamentally, nothing horrendous about it. It's just, as Cam would say, it's about the assumptions that have gone into that we're choosing to use at the moment.
I remembered. My brain went elsewhere, sorry. But I remembered the reason I got into Passive House was we were, modelling all our buildings, getting our 6-star back in the day, and then clients would say, well, but how much heating do I need? Should I put in hydronic heating in my slab? And that, that was the $50,000 cost for a heat pump hydronic. And Cameron knows a story similar to this, I believe, about putting in heating, and could the NatHERS tell us, is that going to be necessary or not? And that modelling could not tell us. And everyone was moving into their 6-star homes and going, aren't I great? How wonderful is my house? And it was still cold, and they had huge heating bills. And so that's when I, 15 years ago now, started learning about Passive House and thought, oh, this modelling is different. It's 95% accurate. There is the performance gap is so tiny to know how much heating or cooling is required, how it's going to perform throughout the year. And that was an absolute game changer, because we could actually tell our clients. And so we run that through all of our projects, because we can give them that peace of mind, and we can save them $50,000, can't we, Cam? Or 20, or whatever the cost might be. But yeah, it helps.
Awesome. Now, building designers, architects in the room, I get to pick on you guys now. So there seems to be a disconnect between the potential of building science and the implementation in actual projects. This is for you, Talina. Now, architects play a crucial role in bridging this gap, but they may face challenges due to a lack of knowledge or maybe outdated principles or practices. How can we empower architects to become champions of building science and effectively communicate that well to clients?
I think it's a real collaborative approach, right? So yes, you can pick on the architects and building designers in the room, but there is a growing awareness in the industry, and people are learning it, but there can be pushback from builders, not the builders in this room, of course.
Totally. I probably should say, yes, there is builders as well that will kick back because it's too hard.
Yeah, so there can be kickback from many people or clients, because I think it might be too expensive. So we focus on talking about the benefits, and once you talk about the benefits, who doesn't want that? There's next to no heating and cooling required, and all of the things.
So I had someone reach out to me recently where they'd gone to their architect and builder in this case and said, hey, we want to build a healthy home, we're looking at Passive House, and they get told it's a whole lot of crap, we don't need to worry about it, code's fine. And the clients keep going back to them to be like, hey, what can we do here? And I was like, well, you probably need to change architect, builder, designer. Yeah. That's probably the situation where I'm talking, where they're not educated or say it's too hard. Like, what can we do?
Come and see us.
Yeah, I understand that, but not everyone. You can't do every project here, yeah.
No.
So how do we get other people bring on that journey? Because it is quite difficult.
It is. Look, it comes to that education, that collaboration, finding that perfect, not the perfect team, finding a team where everyone is on the same page is absolutely crucial to a successful project. Because whether it's the builder, the client, or the designer who might be going off on this tangent, if one party is like, yeah, no, I don't really buy it, it's going to cause problems. It really is. So you definitely need everyone on the same page. And I guess it comes back to continuing education. We can't wait for the building code to catch up. How long are we going to have to wait? So, even in the past 5-10 years, there is exponential growth in the awareness of building science and all this stuff. People are getting excited and talking about it. I feel like the gap that's missing still is real estate agents and media, although saw Dylan here earlier, getting Passive House on TV and things like that is really starting to change things. We've got more coming, is there? I don't know, not me. We're not going on TV. But that awareness has really started to shift. But I think real estate is got a lot to answer for.
Who trusts a real estate agent? All my family are real estate agents, so they'll always tell you something that's wrong.
Yeah.
So
So we need to get a forum for real estate agents so they can learn it's not about another movie room and all of that. I don't know if I'm answering your question. I just think once people learn this stuff, they go, cool, let's do it.
So that probably then asks, so everyone's here today, you're learning things. So if you now walk away from this and you know the answers, but you continue to then implement things in the old way, how do you go about having then that conversation? Because they already know the information, they understand the problems, yet then they continue to keep building a certain way. That's a huge problem because they're almost the worst people because they know the answer. The people who are uneducated and don't know it, that's just unlucky, maybe their fault, whatever. But it's the people that know it are therefore potentially the problem.
I'm all ears for someone who's got a solution to that. So it's the unanswerable question, Matt. So
Yeah, I think it's a shift of people learning to care a bit more too. And some people care about budget and that's it.
And that's fine though, because not every, we got to understand, building's expensive. We all understand that. I don't think there's one person in this room who hasn't had an issue with budget recently. It fucking sucks. I've got 2 projects at the moment that probably aren't going to go to site for this exact reason. So we're trying not to strip back those performance elements, and we actually won't. We'll just pull the pin on the project, and the clients are both on the same page. But that can quite easily go back to the opposite way, where we strip it out, and all of a sudden now we end up with the same problems Dan's talked about with rotting in timbers and all these other things.
Keep sharing all the good stories that are out there, and that awareness builds, and then people say, I want that too. Why? If once you know this stuff, who wouldn't want this, right? We might not all be able to afford it right this minute, but who doesn't want this?
100%. Now, I want to jump back to mechanical ventilation with Joel for a second. So again, my brain jumping everywhere. Can you just explain what a HRV is?
yeah,
Some people might not know what this means.
Yep, and it can get interchanged with ERV, but HRV, heat recovery ventilation, ERV, energy recovery ventilation, they get mixed up, particularly in the commercial sphere a little. There is some very subtle differences around sometimes the type of core inside the unit, whether that allows moisture transfer as well as heat transfer or not. But for Victorian climates, it's pretty clear that HRV is the kind of product you want to look at.
Can you explain how it's balanced and what that means?
Yeah, okay. So we talked about, or you've heard about building airtight. So it obviously doesn't make any sense to then set up a ventilation system that's unbalanced, because we're going to attempt to drive airflow through that airtight wall assembly. So that straight away says, look, we've got to do a balanced arrangement. The other thing that becomes quickly apparent is if you unbalance your airflows too much, the heat recovery efficiency starts to deteriorate quickly. So we probably need to digress a little bit into what's in the centre of a HRV unit in the way of a heat exchanger. And it is essentially octagonal shaped, hexagonal shaped, and a series of plates layered on top of each other. And essentially what we're aiming to do there is pass air streams in opposite directions past each other. So an exhaust air stream coming from within the house to outside, and an outside air stream coming into the house. We want to pass them very close to each other, don't allow mixing, but have a really thin membrane that allows that quick heat transfer. And so having those balanced flow rates enables us to maximise that heat transfer.
Can you explain that it's not a heater for people? And if we do have the conversation sometimes where you probably get people reaching out, like, can we hook our aircon into it or duct it through the aircon or the heater through that? Do you want to maybe explain that a little bit further?
So some technicalities there, yeah. Again, coming back to principles of operation, what we're doing is using the thermal energy that's within the building to precondition outside air. So where that differentiates from a heater is if we let the indoor conditions run away. So for example, in winter, if we let it get really cold inside, we go away, we pull all our blinds down before we go away for several days. There's no solar thermal gains. Indoor temps slump, even in a passive house, they slump. And when you come back, your heat recovery unit is trying to work with very low indoor temps, and there's very little thermal energy left there to recover. So that is definitely why you would need some ancillary heating. So again, even in a passive house, in order to get that indoor temp back up into a stable condition, and then also to enable you to start at a good spot for managing your solar gains and bits and pieces as any building is designed. What was the second part, Matt?
What was it?
Integration with
Yeah,
aircons.
that's the one.
Yeah, so that's a good question. And probably about 6 or 7 years ago, we started down that path of attempting to do some integration. There's some elements that kind of maybe make it look logical, as in an HRV system has a duct network already. If you can reuse that, it's a good option. That duct network is cleanable, so we get away from kind of big ducted AC with flex that's really hard to clean. The fundamental challenge comes back to the building physics around it, and it is that the amount of heating and cooling you need requires higher airflows to be delivered than what the HRV can do. So you would need to substantially oversize your HRV unit in order to have sufficient heating and cooling capacity, because not only do we need to kind of manage steady state, we also need some surplus capacity to manage that time when you do go away on holidays, whether it be winter or summer, and the temps run outside of comfort bands. We don't want to have to wait a day for that to come back. We need to be able to dump some heating and cooling energy into there to get things regulated. The other thing we found was that complexity was a challenge for installers, and that cost really didn't offer any advantages over several splits. You could essentially probably get at least 2.5 to 3 split systems for the same sort of value as this integrated arrangement.
What is often sort of needs to be explained, I suppose. A typical new house might have 100. No, hang on. I'm going to say this wrong now with all the people who know numbers in the rooms. 100 watts of heating load is often what's required in a typical new house, but in a passive house, it's 10 watts of heating load. So we're putting in an air conditioning unit for our heating in a passive house because it also cools. It's got a really low coefficient, good coefficient of performance, so it performs really well. And most people say, I hate air conditioners. They're blowing hot air all the time. They're awful, right? But in a passive house, or when we're doing this building science stuff, you only need like one small one or maybe 2 small ones, whereas some of those new houses, they need full house systems or one in every room to really perform properly. So I just wanted to...
Perform properly or just keep it somewhat comfortable?
Well, yeah,
like,
sorry. To keep it at a nice level,
Yeah, and just picking up on Talina's point about capacity, it probably can be dealt with a 5 kilowatt split. We then get into questions of distribution. So if we put it in the living room, what's the master bed at the other end of the house look like? So we need to balance some of those considerations as well.
But it's such a small amount, like most of our passive house clients, they might put that on, their heating, for an hour in the morning on a cold morning, and it sets, and by the time they get up, it's stopped. So there's no blowing hot air, it's very gentle, it just helps keep the temperature nice and comfortable, so it's not this awful bleh. Yeah.
now, these HRV things, where do they live? Do you put them in the garage? Do you want to talk about the ductwork? Where do they go?
Yeah, okay. So HRV units, think of them as having some level of insulation, but not super high. So if you go and park that, a bit like level of insulation in your building, if you go and park it in a really cold garage, let's say we're in Trentham or somewhere, Kyneton, where it's getting quite cold overnight, you're going to get some level of efficiency loss. So ideally, lives within the thermal envelope. Service rooms are a great spot for it. So there's some potential for case radiated noise on any kind of unit. Better that is in a service room like a mudroom or a laundry rather than being in a walk-in robe. You'll also have drainage already plumbed into those areas. You need some drainage with a HRV unit to catch condensation and things.
And that one always gets missed by people doing it for the first time.
It does. And so if you're in a laundry, you've got half a chance of getting to a drain point versus your walk-in robe.
Drew will kill you if you don't put in your condensation pipes. Now, ductwork, a lot of architects or designers will try and get the 90mm because that's the size of the duct, but really typically we need 140mm because, do you want to explain why? Because it's a real common problem. And it's happened on my own projects, you try to avoid it, sometimes you can't.
Yep. So one of the common traps is, hey, what's the duct size we're using? And 90mm is a pretty common size. So, hey, I'll design to 90mm service cavity. First of all, your HRV contractor is going to kill you because dragging a 90mm duct through a 90mm service cavity just doesn't really work. So you need more than that. Secondarily, that duct, you can visualise, is coming to a grill somewhere or a grill housing. And so that housing naturally has to be bigger than what that duct size is. So we've got an expansion there. The third point is that unless you want to go around and trim out bits through your top plates, you actually need to provide a little more to clear internal wall frames. So 140mm is kind of ultimately where we end up with that kind of service cavity size.
All right, next topic. So we've talked about air tightness. Intallo is a product that Proclima have. What are your thoughts on plasterboard air tightness?
Well, it's dangerous, I suppose. It's very difficult to get good air tightness just with plasterboard. And even if you get at the time of construction, you're not guaranteed that it's going to be there for the life of the building.
Why is that?
Because as soon as the owner or a tenant comes in and punch a hole in the wall to put the pictures, there you go, done.
Well, the house also moves as well, yeah? So potentially cracks.
Yeah.
But hypothetically, what if you start using these boxes behind the wall or special downlight covers and all these other things? Well, that still doesn't answer the first question, does it? Or your first statement?
Yeah, well, I suppose that they're never gonna be as perfect as a dedicated air tightness membrane that is there and it's been designed and it's been installed to do that role.
I know in the passive house community, and it might be some of the people in this room, that it's very possible to get very low air tightness rates only using your external membrane and taping all of that up and sealing all of that. But then that comes back to Cameron's presentation about the perfect wall, and if that's your air tightness strategy, what is that doing with your condensation movement if it's only your external membrane? But yes, you can do that, and that's not necessarily it's not really relying on plasterboard, but it's making, if that's taped up and sealed up, you can get very low rates, and you need to then make sure it's ventilated.
What is air tightness, and what this magical question of, I know you love this question, Joel, like what should we be considering air tightness, or what is airtight?
Okay, so clearly at one end of the spectrum we've got kind of passive house level air tightness. So we're right down at sort of that under 1 air change per hour, 0.6. So we're testing, most of you are probably familiar with blower door tests. We're using that to assess the amount of leakage that's happening through our building. We're doing that in a pressurisation and a depressurisation because we want to make sure it doesn't leak in either of those scenarios. And those scenarios can both happen. If you imagine strong wind on upwind side applies pressure to your building envelope, but equally on the leeward side you've got a negative pressure. So hence we're testing for those. And essentially we're looking to stop that air / moisture transfer through our assemblies.
Anything else? No. All right, Rob. Now you're in the process about to retrofit your own house. Do you want to talk about what's currently there? What are you thinking of doing? What's running through your brain? It hasn't started yet, so there's obviously some form of change potentially that might happen, or you don't know what you're going to do. Do you want to talk about what your process is going through that project?
Yeah. Well, I started this process probably 8 years ago when I moved in my current property. It is a brick veneer construction, concrete slab on ground, clay tiles, exactly the scenarios that was discussed before. So a bit of a nightmare from a retrofit point of view. And when I first moved in, the first thing I've done was probably all the wrong thing that you will do. I put in ceiling insulation. I blow in insulation into the cavities, and then solar panels and all the bits and pieces. So probably I've upset the house a little bit, or the balance of the house. And now I guess I'm thinking, how do I go about it, and how do I make it better into the future? Recently this year I put new windows in. That's been good. UPVC windows that made such a big difference thermally, but more importantly acoustically. They're fantastic, even if they're not like top of the range. So what I'm thinking now is exactly what was discussed before. So external insulation to the walls, wood fiber board, or probably a membrane between the brick and the wood fiber maybe, and then a rain screen, and running that membrane, redoing the whole roof, and running the membrane on top of the new roof. I'll probably want to wait another 5, 6, 7 years before doing that, because I don't want to take down the almost new PV panels.
So you said you're going to put brickwork, and I know your old house, I know you're going to hate this question. So the old bricks that you have are the ones that have the holes on the inside, and you're about to now wax some external insulation wood fibre. Now, there might be air moving through those cavity of those internal parts of the bricks through those little holes. Does that have any problem with now affecting the performance of the insulation because that air cavity is not still?
Well, of the future insulation?
Of the future, if you were to put the wood fibre on top of that.
Well, I will assume that if you run your membrane, your weather-resistant membrane on the outside of the brick and then up, and you basically enclose that space, that would become like steel here or inside here. So I don't necessarily see an issue with that, but we'll see. We can put some sensors in somewhere in the wall.
Should we be censoring most houses when we do retrofits, because there's a lot of unknowns?
I wouldn't say all houses, but I think that we should probably monitor a little bit. Some houses, some existing stock, get some understanding of what's happening, not just inside the spaces, but also within cavities.
All right, so I think this is probably my last question before we start to hand it over to everyone here and hit them with some very hard questions. But Talina, there's probably this idea with building science that they need to be boxy, boring houses. Do you want to maybe talk about form factor and how this maybe might affect the house? This actually question is from Andy. So I asked Andy what might be a question that might throw you off. He told me to ask you maybe something around form factor.
I thought that would be a question that's come from Cameron, because he's laughing at me. So our very first, my very first passive house was our Woods passive house, which we designed before we decided to turn it into a certified passive house. So it's a pavilion style with kind of 3 blocks, and they've got little links. It's not an ideal form factor, because the best building shape is a sphere. Isn't that how the building science goes? minimum surface area. And a cube is probably the next best, or as we were talking about in the break, to have, like terrace houses or houses that are up against each other. Each house is insulating the next one, so that's actually way better than a standalone house in a field. It just so happens I live somewhere where we have a lot of standalone houses in fields, because that's what people do in the country if they have a block of land. So this, and it's about outdoor rooms and connecting to the environment and all of that. So we designed this one and figured out, yes, it could become a passive house. It didn't have to be a box, but it just meant our walls had to get much thicker. And this is an ongoing story with a lot of projects. You can do it, absolutely. You can have a lovely big sprawling thing, but you've got way more surface area, a lot more walls, and those walls need more insulation. Easy to get more insulation in the roof, because unless you're trying to do a really flat roof, which we know we're not meant to be doing because they're bad. So if we've got a nice big pitched roof, we can get tons of insulation up there, but you do reach a point of, well, we're at R10 now, how much more are we going to go? Floors, we can get whether it's an insulated slab, and you can do that a few different ways, or the insulated timber frame floor, we do that a bunch of ways. So there's lots of options for roof and then floor, walls, getting fatter. It's just, even to go to 140 from 90, it's double the cost in timber to do that. Should be the same labour, surely.
But what if you run at 600 centres, you're now reducing the amount of timber?
Well, that's helpful if your builder will do that, and the engineer and sign off on that, and the building surveyor's okay, so yes.
But it's part of the 1684, like you're able to frame it 600 centres.
Beautiful, and Californian corners, and
easy.
all that. Like, so there are, there's ways. So yes.
Sorry, I'm not picking you apart. I just want to start the
go for it.
conversation.
So I think that's why that project got attention, because if from the start we had have said, let's do a passive house, and German-style passive house, we might have said, let's do a lovely 2-story box, because it works. And to be fair, we are doing a lot more boxy boxes now because of budget, but that doesn't mean they have to be boring. They can be lovely. Ben and I went to visit one this morning that's under construction. We think it's pretty lovely. It's a box, but it's going to be a really nice box. And it's only got 140 walls, so we were happy.
Awesome. Now, Haim's going to roam around with the mic. Don't be afraid to ask any questions, because I've kind of run out of a few.
But basically, you can build... Aesthetics is not limited by the passive house criteria, but it helps to understand, the limitations.
Speaking about 90 and the comparison between 90 and 140 mil walls and 600 centres and whatnot, has anyone ever done a staggered stud wall just to maintain that continuity and the thermal insulation?
I think we've talked about it with builders. We did it was meant to be 300 LVLs for this one project during COVID. Couldn't get them, so it ended up with 2 140s or 2 90s, but so they were staggered and then crammed full of insulation, but not quite in the way you're saying. But we've definitely talked about it. We've done
you're
like
framing
15...
twice though. You're starting to frame twice, which then becomes labour, and labour is expensive. So
it was expensive, but we've done like a dozen different wall types for passive house. There's no one right way. They're not all, they've all got limitations. There's all pros and cons.
And my knowledge here in a builder, you just essentially go 140, then insulate externally with wood fibre board, 60 mil. It's probably around $60 a square metre supply. It's now becoming readily available. So as those prices drop, it becomes easier to hit those different wall types from a builder and architect and designer to get to that end result without throwing a ton of labour at it to get there.
And it's normal in Europe and other parts of the world. It's just we're a bit slow. And so it should be, 140 stud should be the normal in this climate, and have other options.
Sheathing the outside will also reduce all that thermal bridges as well for the studs.
Thanks. So the NatHERS tool we spoke about earlier, one of the underlying assumptions in that tool is that people throw open their windows when the outside conditions are ideal, and they obviously get ventilation through that means. Whether they do or don't, it's an assumption. The passive house is using airtightness and a heat recovery ventilation strategy. no builder in this room's doing it, but what if a client approaches you and says, right, I don't want to get a passive certified house, but I want massively increased airtightness on what NatHERS requires, but I don't have the budget for a heat recovery ventilation. What are we doing?
Don't build it.
Panic. So it's an interesting point, and I would say the operable window stuff that's assumed in NATHERS and Passive House is actually about purge cooling and temperature control. Ventilation, unfortunately, is almost non-existent in the building code. Like, yeah, there's a thing that talks about ventilation, but it talks about bathroom exhaust fans, like remove condensation. Nothing that talks about indoor air quality. Interestingly, there's an ABCB indoor air quality handbook, so they know of it, but it's yet to make its way really into any enforceable part of code. I can't remember
Can
the
I add
rest.
something here? Didn't Dan before showcase there that now that the mold index are greater than 3, we're now liable that we don't comply with the code? So then couldn't we potentially get sued? So therefore you put it in, and as aren't we responsible to educate the client and then go, no, this needs to go in, or we could get sued?
I think that's an awesome point. It de-risks construction for builders. So that.
But architects too, like they're
architects-
liable.
Henrik, have you been following that discussion through? Do you want to respond to that? Because I can't remember, but in the Archi Team forum, there's been a whole discussion around buildings weren't going to, or PI insurance was not going to cover mould in buildings. Over to you. Thank you.
I wasn't on the forums in the last few days, but it's coming up again and again, isn't it? I'm not exactly definitive sure whether my PI insurance is bailing out or out of mold risk, but I think it is the trend that insurers just put clauses in and then leave the designers alone with the risk. Super concerning. Back to the original question, I would definitely spend, if needed, 10 hours consulting the client and advising that it's a must.
But it's the
in
reasonable
airtight
person test though. So as a client, they're the reasonable person, wouldn't they be? Like we're the ones that are educated. It's on us to educate them that no, you need it.
Yes, I see it as a role of the architect or building designer to educate the client. That's for sure. That's part of our job, yeah.
Yeah. Well, that's how we got our first passive house, pretty much, wasn't it? It's very easy. Do you have a question, don't you?
I just had a question about the HRV and leaving that on during holidays, I guess.
Yeah.
Is that the advice to do that, even if you're going away for months?
Yep. Yep, definitely. So there's probably a few things. There is still some of that moisture migration that we heard about through wall and roof assemblies. So we want a little bit of airflow to make sure we're still taking that out of the building. The other thing is we don't want to allow moisture into our ductwork without some airflow. So potentially you've had a shower before you head off on holidays for a few months and you've run the HRV and it's got just a little layer of moisture through your ductwork or your heat exchanger. You don't want to take the risk of leaving that. In typically away mode is what they're called. They're probably using about 10 to 15 watts. So it's tiny energy consumption.
We recently had our clients up in, or some of our clients in Central Victoria go away for a couple of weeks and put it in away mode, and they came back and they went, this is in the middle of winter, and they walked inside and they're like, oh, did we leave the heating on? No one had been in the house for that couple of weeks and it was perfectly comfortable inside and it was still freezing outside. So they are just like, they are so happy with their home because until you experience it, it's hard to know.
Can I follow on from that and from your earlier question too? If the HRV is going to improve things that much, going to an old house, double brick home, usually has brick vents because they're really, really tightly sealed otherwise, without having the budget to rip off the brickwork or the heritage architect to justify doing that, how much of a difference would it make to the home to seal up those brick vents maybe do something to the timber floor and put an HRV system in?
Yeah, okay. And so there's probably a few parts to that question. Sealing up your brick vents and weep holes is probably something best discussed with someone who's a
Don't seal
specialist.
the weep holes at all.
Yeah, in that space. But it's kind of pointing to the age-old question of how airtight do I need to be before HRV makes sense. Now, there's still a bit of literature kicking around that talks about 5 air changes per hour. That's probably been debunked a little bit. There's some later stuff that correctly points out that there's not a line in the sand, one side of which is great and one side which is shit. So what I'd say is out at high levels of leakiness, so let's call it 10 air changes per hour, you start looking for some high-low run bathroom exhaust fans. So they give you a boosted flow rate when you're showering, and they drop back to a lower baseline. So they give you a bit of continuous ventilation.
And they should be on a timer?
They probably run continuous. So you might only be down at sort of 8 litres a second or something, a fairly low level. That's going to give you really good drying out of your bathroom over the course of the day, so no moisture risk. Hopefully it's going to draw a little bit of air into your building, a little bit of fresh air as well. Yes, there's some risks about that air path that it's taking. Is it coming through your roof structure and so forth over your rat droppings in the roof, or is it coming through a window? As you come down that airtightness scale, then you start to look at more balanced systems, and you might start at a decentralised, say through wall. The sort of push-pull type system is the really entry-level stuff. So maybe at 7 air changes per hour, you start looking at that, and as you work your way down, you increase your spend. You can get to entry-level ducted stuff and then higher quality ducted stuff. That's probably the best answer.
It's decentralised about 50 square metres repaired?
So it's going to vary a little bit depending on room use. The decentralised you can't use in wet areas, or this push-pull style of decentralised, because you are going to drive moisture or odour out into other parts of the building. And so that sort of stuff is more for habitable spaces, so living, bedroom, dining, so on and so on. You still need to tackle your wet areas really with a ceiling mounted kind of extraction.
Mr. Nook.
Hamish. Decentralised HRVs. So if you do have a brave builder that did go and build the house without a HRV system, and we can't run ducts for a centralised.
We're not talking anyone in specific here.
No, we're not.
Not
pointing
construction?
fingers. No. We'll see.
Asking for a friend.
Yeah, that's it. So is a decentralised system, a good avenue if someone is in that position? I think it's going to be a big thing in the future that we have built homes too tight. Proclaim an amazing marketing team. People are buying these amazing membranes. They're putting it on without potentially knowing the risks, or measuring their buildings. They're actually testing them to see how tight they are. So worst case scenario, homeowner, brand new house, they're finding it very sweaty, kind of gross to be in. Is a decentralised system a good option?
Yeah, absolutely. So essentially you really just need to be able to get power to those locations. So get your Sparky back in and get him to drop some power. Think about wall thickness. Most decentralised systems are going to need up close to 300 mil of effective wall thickness. So just have a little bit of a think about what your standard construction is, usually nothing like that. So you're going to need to kind of pack internally, externally. But yeah, they're good retrofit options in that respect. There's a couple of styles. There's the entry-level push-pull, which is a paired set. So you'd put one head in one room and another head in another room, and you essentially get air movement between the two. Just to digress a little, essentially they've got a ceramic core, which if you think of that being a heat battery, so warm inside in the middle of winter because you've used a little bit of heating. As it extracts that air, it's warming up that ceramic core. When it reverses its direction 60 seconds later, cold air comes in, it releases that heat into that airstream. So that's why they need to be in a paired arrangement and they need to push-pull. The next kind of step up in that decentralised market is a single point, which has got a more conventional type heat exchanger with continuous flows. Now, you'll get better heat recovery efficiencies, you typically get better filtration, they're a little bit more expensive to apply. That's about the difference.
Thanks, Joel.
Yeah, but you're right that problem is going to keep happening because not enough people are voluntary blower door testing yet, and builders in the room, please do.
Well, this goes on to New Zealand with their leaky building syndrome, where I think is it now a $64 billion problem to knock down the houses. Yeah. So, if we essentially Australia is the dumbest of all because we're following Canada and then we're following New Zealand, and we're just dumb enough to be like, let's do what they did and fuck shit up.
So to be able to test and just know where the benchmark is, because a lot of builders then, when they do it for the first time, they're like, oh, actually, that wasn't that hard. And, well, sometimes, depending what you're aiming for. But I wanted to ask more, maybe a question for Dan about Europe. Isn't ventilation just standard in buildings? And
he's probably going to go that Wolfie now.
2 more questions after this. The funny thing is I was thinking if I should throw a spanner into the conversation. Because I grew up in a very tight house, like old house, super airtight, well insulated, and no ventilation system. So why do you think it was working?
Because the whole system was breathable, maybe, that you had across from one system to the other. Maybe a lime-based plaster, through a wood fibre, through a...
No, it was just plasterboard and bricks and all the other stuff. So the reason is why it can work is because it's manual ventilation. So it means we open and close the windows and doors because it's part of the German culture. So the first thing you do in the morning, you open up and close the windows for 5 to 10 minutes, and you do it the same in the evening. But why is it working? The first is it works better the colder it is outside. So it means kind of if it's really cold outside, you open up, you have a high exchange rate straight away. You don't really cool down this place much, so the air, the warm air is lost, yes, but the surface areas, they stay warm. So that's why you close the door and it's warm again after 10, 20 minutes straight away. So that's why it is working as part of the culture. Of course, you have the energy loss. So now we transfer the same thing here to Australia. Would it work in Melbourne? I think eventually it could work. Would it work in Sydney? Also, I don't think so, because like I measure the humidity in Sydney also, and you have constant over weeks and weeks and weeks, 80% humidity outside. So now imagine you drag in 30 degrees humidity from the outside to the inside, you cool down all the air, and then you end up with massive condensation. So I'm just saying it's because it works in colder climate, it doesn't mean it will work in Australia because the conditions are completely different. So we really have to understand whatever we try to copy from Europe or Germany, wherever it is, it doesn't mean it will apply here.
I think Joel's got something to say here.
All right, were you...
Until we put our kids into kindergarten and teach them the window motion
Just
class, we got a little way to go. Okay.
What were you doing for active heating? Were you heating the building? Yes, you were. No, I'm just saying, but were you heating the building continually? That's right. So we're trying to get away from that. Yeah.
Give him a hug, Dan. The crazy German's about to get angry.
This one is just relating back to like the mould ingress and that sort of stuff. Obviously, at the moment, really wet outside. I'm sure there's supposed to be a dust windstorm coming around. There's a lot of frames going around at the moment, bottom plates. Is there? I know in Tassie, obviously as well, down there's a lot of wet. It's always wet. Is there a solution to keep that mould ingress other than like framing in summer, framing in, you're having a pre-wrapped, fab frame come in, like, if that makes sense. I'm wondering if that's a common...
I understand what you're saying. So there are some systems I've seen come recently that have like a bit of a packer under the bottom of the frame. Again, how you would set them out so they don't move, but then you continue that airtightness layer. Something you could look at, again, engineer would need to sign that off if you've got a structural load-bearing wall and that's sitting on maybe a window packer. Is that structural enough? Then what if that cracks in the future, falls out? So that's something that might be an option. Someone else can try that first and then let me know how it goes. I think the thing is that you're probably got to look at here from a building perspective is understand it's probably going to get wet. But again, wetting is okay if it's followed by drying, okay? And maybe just getting a moisture reader and testing it, not those shitty Azedo ones, like a proper moisture reader. But again, it's a hard one because we kind of can't, all right? We unfortunately, like, it's raining today. I think in Germany, Dan, you get sued if you get mold on any of your frames, don't you at all? Is that right? So a lot of Europe, just from my understanding, is prefab. I think, is it Germany's about 60%, some parts, I think Denmark's around 85 from memory. But like, is this something that we'll see in the future, do you think? So I'm just going to call you out here. When you're on our podcast, though, we asked you how you would build if you're going to build your house, how would you build it? And you said you would use big, thick studs, timber frame it on site, and then put your wood fibre. So isn't that then going against everything what you've kind of just said? And they were your own words. We asked you, what would you do? Yeah. How's that go with the neighbours? 6 a.m. No, but I 100% agree, but we need investment from government to make this viable.
I reckon Glencoe's ears are pricking up here. There's a question back here.
Regime for the HRV units and that system.
Yep. So typically we're seeing, based on Oz experience, that about 6 months is where you'd need to do a filter change on your HRV systems. Now, one of the advantages of using the semi-rigid duct network, that duct system, that high-performance one, is that's cleanable. So unlike ducted AC, which is pretty challenging to clean, you probably would look at that at maybe somewhere 3 to 5 years. And so our recommendation is probably in that 3 to 5 year range. You probably want to get a contractor out to just have a quick look over it. And hopefully that's a pretty quick look. That's pop the front off the unit, have a look at the core, make sure that's clean, check the fans, give them a wipe out. You might pull those quickly to do a decent wipe out on those. Inspect the ductwork. There is a duct cleaning tool, so again, that can be easily done. So keeping on top of those things is not only a good health thing, it's also going to give longevity to your equipment. You're getting less dust through your fan bearings and things like that.